Ever get that that feeling like things are, connected in ways we don't quite get?
Mm-hmm.
Well, that's where we're headed today, into the quantum realm with quantum entanglement.
Yeah.
We're talking particles linked across any distance. Imagine, like, across the universe,
Right.
defying, all the usual stuff about space and time. It's wild. Einstein even called it spooky action at a distance.
Yeah, he wasn't a fan.
So, are you ready to unlock some of these mysteries? From, the science to tech to maybe even what reality is.
Let's do it.
Okay, cool. Before we go too far, what exactly is quantum entanglement?
So picture this. Two tiny, tiny particles, smaller than atoms, right? But they're linked. Their fates are, tied together. No matter how far apart they are, measure one. Say we're looking at its spin. We instantly know the other's spin, even light years away.
Wait, so you're saying this is, actually proven? This isn't just, a theory?
Oh, it's real. Tons of experiments confirm it.
Yeah.
To really get how big this is, we got to go back to the start of quantum mechanics, when even Einstein was struggling with it.
Okay, now that's what I call a deep dive. History and mind-bending physics. So, Einstein, the relativity guy. How do you feel about this entanglement thing?
Even him.
Right.
Revolutionized how we see gravity, space, time. But this. He called it spooky action at a distance, because it seemed to break his own rule.
Yeah.
Nothing's faster than light.
So how are these particles talking so fast? What was his explanation?
He thought there had to be something else going on. Hidden variables, like preset stuff we couldn't see yet that was influencing them.
So they were basically like, it's not magic, we're just missing something.
Exactly. He even worked on a paper, the EPR paradox, arguing against entanglement.
But if they're hidden, how do you prove if they're real?
And that is the million-dollar question. Then in the 60s, this physicist, John Bell, he comes up with this theorem, a way to actually test for these variables.
We could finally do something to figure it out, not just think about it.
Exactly. And the results? Experiment after experiment shows no hidden variables. Entanglement is real, and it breaks how we used to think about physics.
Okay, now I'm really hooked.
Yeah.
But how? What's actually happening down there that makes this spooky action work?
Think of it like a pair of earbuds, all tangled up, you pull on one.
The other one moves instantly, right? Even though it's a mess.
Exactly. Now, entangled particles, they're like that, but they're linked by quantum laws, not wires. And this link, it comes from two things, superposition and non-locality.
Okay. Those sound like words that need some explaining.
Right. So superposition is this wild idea. Particles can be in multiple states at the same time until we look.
Hold on. So it's like a coin being a heads and tails until you check.
You got it. And when we measure it, it's like it has to choose. And that instantly affects the other entangled particle.
Whoa. Okay. And what about the other one?
Non-locality. That's where distance doesn't matter. These particles aren't two things. They're one system, no matter how far apart.
Like they have their own language or something. But this isn't just like a physics textbook thing, right? What can we actually do with this? So we've got these super connected particles. What's the big deal? What can we do with that?
Well, imagine a computer. So fast, it makes today's look like, toys.
Okay, yeah. Like how fast are we talking?
Solving problems in minutes. That would take normal computers billions of years. That's quantum computing.
No way. That's insane. How's it even work?
Qubits, they're like the building blocks, right? But instead of just being a 0 or a 1.
Like the bits in our phones and stuff.
Right. A qubit can be both at the same time. Superposition, remember?
Oh, right. And entanglement is what connects them up.
Exactly. You get this whole network of qubits all exploring tons of possibilities at once.
Not just stuck doing one little calculation at a time, like our current stuff.
Exactly.
Yeah.
And the more you connect,
Yeah.
the more powerful it gets. It's exponential. Drug discovery, new materials, even breaking the toughest codes.
Now, about those codes, quantum entanglement can make them, unbreakable. I've heard that, but it sounds kind of far-fetched.
Quantum cryptography. It's a real thing. Picture this. Someone tries to snoop on your entangled particles. They actually break the entanglement.
Wait, seriously, so you instantly know if someone's listening in?
Boom. Data theft becomes basically impossible. And scientists are already working on this.
How? Is there an example of that?
China launched a satellite, MISSIS. It actually sends entangled photons from space down to Earth.
Hold up, space? We're messing with this stuff from space. Are we getting into, teleportation territory here, like Star Trek?
Not quite beaming people up yet, but
Yeah.
teleporting information.
Yeah.
Yeah, that's happening instantly across huge distances. That's MISSIS.
It's just wild to think we're doing all this with something that even Einstein, like, couldn't wrap his head around.
Right.
But it's not just about the tech, right? You said it yourself. This entanglement thing.
Right.
It's like a whole new way to understand the universe. We're messing with some fundamental stuff here, like what's real, how it all works.
It really makes you question everything.
So, like, what kind of cosmic stuff are we talking? Give me the big picture implications.
Think about cause and effect. Every effect has a cause. Right. Things happen in order. Makes sense, yeah.
Yeah, pretty basic stuff.
But entanglement throws that out the window.
Mm-hmm.
If these particles are influencing each other instantly across the universe...
There's no way that order makes sense anymore.
Exactly. Time, space.
Ah.
And it all gets blurry. It suggests the universe way weirder, way more connected than we thought.
So our whole understanding of how things work could be, like, totally wrong just because of this entanglement thing.
It's a possibility, and an exciting one. Some physicists even believe entanglement could be the key to finally unifying those two big theories, quantum mechanics and general relativity.
Wait, hold on. The theory of everything, like the holy grail of physics, entanglement could bridge that gap. Are there even theories out there that try to explain how entanglement fits into all of this? Theories like, what are we even talking about here? How does this all fit together?
Well, there's this idea called the holographic principle. It's pretty wild.
Holographic principle. Okay, now we're definitely in sci-fi territory.
Right. It sounds crazy. But basically, it says that our reality, 3D, everything we experience,
Yeah.
it might just be a projection.
A projection of what?
Information encoded on some, like, distant surface. Think of a hologram. Looks 3D, but it's all coming from a flat image.
So you're saying the universe is like a giant movie, and we're all just watching it?
Kinda. And some physicists think entanglement is how it works. The thread connecting our 3D world to that hidden information.
Like, hold on. That's a lot to process. So it's not just that our TVs are showing us a picture. It's that the picture is, like, fundamentally linked to something else entirely.
Exactly. And the crazy thing is, this isn't just theory anymore. Experiments like that Misha satellite, sending entangled stuff into space, we're actually testing this stuff.
It's kind of mind-blowing, honestly. When you really think about it, I gotta ask, after all this, is entanglement still spooky to you? Or do you just, like, get it now?
Honestly, every time I think I'm close, it finds a way to surprise me. That's what's so cool about it. We're still figuring this stuff out. There's so much more to learn.
I guess Einstein was right. Spooky action at a distance. But we're not afraid of it anymore. We're using it to build new tech, to figure out what this universe is really about.
It's a whole new era of discovery. And it's all thanks to this one weird thing.
So, to everyone listening, what if this entanglement thing, as weird as it sounds, what if it holds the answers to everything? It's the theory of everything, the nature of reality. It's a wild thought. But one thing's for sure, figuring it all out is going to be one heck of a ride. So keep asking questions, keep exploring, and never be afraid to get a little spooky with your thinking.